Plenum design guidelines for arc-resistant switchgear begin with material selection. Use 11-gauge steel or thicker. Galvanized or stainless steel are suitable choices for corrosion protection. Flanges are critical for connecting to the switchgear. Use bolted or welded flanges. The size of the flanges should match the switchgear exhaust port dimensions. Determining the proper plenum size is essential. First, determine the required exhaust flow rate for the specific switchgear model. Design the plenum capacity accordingly. The height of the plenum is typically between 12 and 24 inches high to provide sufficient airflow. The width and length of the plenum are determined by the available space and the switchgear dimensions. Bracing is essential to maintain structural integrity. The plenum should be adequately braced to prevent deformation or collapse under the weight of the exhaust gases and potential pressure surges. Use steel angles or beams for support and bracing. Proper installation practices are vital for effective operation. Install the plenum vertically above the switchgear exhaust port. Seal all joints and connections to prevent air leakage. Ensure there is sufficient clearance around the plenum for maintenance and access. Ventilation system integration is a key consideration. Connect the plenum to an exhaust system that is specifically designed to handle the expected volume and temperature of the exhaust gases released during an arc flash event. Install louvered openings at the top of the plenum. These louvers allow for air intake and help to prevent moisture buildup within the plenum. Consider insulating the plenum to minimize heat transfer to the surrounding area, particularly in enclosed electrical rooms. Clearly label the plenum as arc exhaust. Include any necessary safety warnings to alert personnel to the potential hazards. When considering the National Electrical Code, refer to Article 110.3 b, which covers the installation and use of listed or labeled equipment. Equipment that is listed or labeled must be installed and used in accordance with any instructions included in the listing or labeling. For arc-resistant switchgear, this means following the manufacturer's instructions for installation and any requirements for the exhaust plenum. Article 408 covers switchboards, switchgear, and panel boards. While it doesn't specifically address arc-resistant switchgear, it does provide general requirements for the construction, installation, and wiring of these types of equipment. Article 408.56 covers the available fault current. Switchgear and switchboards must be marked with the available fault current at the supply terminals. This information is important for ensuring that the equipment is properly protected against overcurrents. Article 408.58 covers the overcurrent protection. Switchgear and switchboards must be protected against overcurrents by fuses or circuit breakers. The overcurrent protective devices must be sized and selected in accordance with the NEC requirements. Article 408.70 covers the grounding of switchgear and switchboards. Switchgear and switchboards must be properly grounded to provide a path for fault current and to minimize the risk of electric shock. Article 408.72 covers the bonding of metal enclosures. Metal enclosures of switchgear and switchboards must be bonded together to create a low impedance path for fault current. UL 508 is the standard for industrial control panels. While it doesn't directly cover switchgear, it does provide useful information on the construction and wiring of electrical enclosures. Chapter 2 of UL 508 covers the general requirements for industrial control panels, including the enclosure, wiring, and components. Chapter 5 covers the wiring methods. It specifies the types of wiring that are permitted to be used in industrial control panels and the requirements for installing and supporting the wiring. Chapter 6 covers the overcurrent protection. It specifies the requirements for fuses and circuit breakers used in industrial control panels. Chapter 7 covers the grounding and bonding. It specifies the requirements for grounding and bonding the metal parts of industrial control panels. The exhaust flow rate for the switchgear is a critical parameter for plenum design. This flow rate is determined by the switchgear manufacturer and is based on the amount of energy released during an arc flash event. The plenum must be sized to handle this flow rate without creating excessive back pressure. The plenum's height is important for providing adequate airflow. A taller plenum will generally provide better airflow than a shorter plenum. However, the height of the plenum is also limited by the available space. The plenum's width and length are determined by the available space and the switchgear dimensions. The plenum should be sized to fit within the available space without obstructing access to the switchgear or other equipment. Bracing is essential for maintaining the structural integrity of the plenum. The plenum must be able to withstand the weight of the exhaust gases and any potential pressure surges. Steel angles or beams can be used to provide support and bracing. When installing the plenum, it is important to seal all joints and connections to prevent air leakage. Air leakage can reduce the effectiveness of the plenum and can also create a fire hazard. Sufficient clearance around the plenum is necessary for maintenance and access. This clearance allows workers to safely inspect and maintain the plenum. The ventilation system connected to the plenum must be designed to handle the volume and temperature of the exhaust gases. The ventilation system should also be equipped with a filter to remove any particulate matter from the exhaust gases. Louvered openings at the top of the plenum allow for air intake and help to prevent moisture buildup. These louvers should be sized to provide adequate airflow without allowing rain or snow to enter the plenum. Insulating the plenum can minimize heat transfer to the surrounding area. This is particularly important in enclosed electrical rooms where excessive heat can damage equipment or create a fire hazard. Clearly labeling the plenum as arc exhaust and including any necessary safety warnings alerts personnel to the potential hazards. This labeling helps to prevent accidental contact with the plenum during an arc flash event. Consider the exhaust flow rate specified by the switchgear manufacturer. This is usually expressed in cubic feet per minute, or CFM, or cubic meters per second. The plenum must be sized to handle this flow rate without creating excessive back pressure. A common range for exhaust flow rates in medium voltage switchgear is between 5,000 and 20,000 CFM, but this can vary depending on the specific equipment. For example, a specific model of arc-resistant switchgear might have a listed exhaust flow rate of 12,000 CFM during an arc flash event. This value would be a starting point for calculating the required plenum volume. The height of the plenum is typically in the range of 12 to 24 inches. This height provides sufficient airflow while also minimizing the overall size of the plenum. However, the exact height may need to be adjusted based on the specific application. For example, if the plenum is located in a confined space, a shorter height may be necessary. The width and length of the plenum are determined by the available space and the switchgear dimensions. The plenum should be sized to fit within the available space without obstructing access to the switchgear or other equipment. Common dimensions for the width and length of the plenum are in the range of 3 to 6 feet, but this can vary widely depending on the specific installation. Bracing should be designed to withstand the weight of the plenum and the exhaust gases. Steel angles or beams can be used for support and bracing. The size and spacing of the bracing members will depend on the size of the plenum and the expected loads. For example, a large plenum may require heavier bracing members and closer spacing to provide adequate support. Sealing all joints and connections is crucial to prevent air leakage. Air leakage can reduce the effectiveness of the plenum and can also create a fire hazard. Sealants and gaskets can be used to seal the joints and connections. For example, a high-temperature silicone sealant can be used to seal the joints between the plenum sections. Sufficient clearance around the plenum is necessary for maintenance and access. This clearance allows workers to safely inspect and maintain the plenum. A minimum clearance of 3 feet is typically recommended around the plenum. The ventilation system connected to the plenum must be designed to handle the volume and temperature of the exhaust gases. The ventilation system should also be equipped with a filter to remove any particulate matter from the exhaust gases. The ventilation system should be sized to handle the exhaust flow rate specified by the switchgear manufacturer. For example, if the switchgear has an exhaust flow rate of 12,000 CFM, the ventilation system should be capable of handling at least that flow rate. Louvered openings at the top of the plenum allow for air intake and help to prevent moisture buildup. These louvers should be sized to provide adequate airflow without allowing rain or snow to enter the plenum. The size of the louvered openings will depend on the size of the plenum and the expected airflow rate. For example, a large plenum may require larger louvered openings to provide adequate airflow. Insulating the plenum can minimize heat transfer to the surrounding area. This is particularly important in enclosed electrical rooms, where excessive heat can damage equipment or create a fire hazard. Insulation materials such as fiberglass or mineral wool can be used to insulate the plenum. The thickness of the insulation will depend on the desired level of heat transfer reduction. Clearly labeling the plenum as arc exhaust and including any necessary safety warnings alerts personnel to the potential hazards. This labeling helps to prevent accidental contact with the plenum during an arc flash event. The labeling should be durable and easily visible. The warning should clearly indicate the potential hazards associated with the plenum. Galvanized steel offers corrosion protection but may not be suitable for highly corrosive environments. Stainless steel provides superior corrosion resistance. The choice depends on the specific environmental conditions. Bolted flanges allow for easier disassembly and maintenance, while welded flanges provide a stronger, more permanent connection. Consider the long-term maintenance requirements when selecting the flange type. The exhaust flow rate is determined by the switchgear manufacturer based on the potential energy released during an arc flash. This information is crucial for properly sizing the plenum. Consult the switchgear documentation for the specific exhaust flow rate. The plenum's height affects airflow and pressure drop. A taller plenum can reduce back pressure but may require more space. Optimize the height based on space constraints and airflow requirements. The width and length of the plenum should be proportional to the switchgear dimensions and the available space. Avoid sharp bends or constrictions in the plenum design, as these can increase back pressure. Steel angles or beams provide structural support to prevent deformation or collapse of the plenum. The size and spacing of the bracing members depend on the plenum's size and the expected loads. Proper sealing prevents air leakage, which can reduce the effectiveness of the exhaust system and create safety hazards. Use appropriate gaskets and sealants for the specific materials and operating conditions. Sufficient clearance around the plenum allows for inspection, maintenance, and repairs. Consider the space needed for personnel to access the plenum and perform necessary tasks. The exhaust system should be designed to handle the volume and temperature of the exhaust gases. Ensure that the system complies with all applicable codes and standards. Louvered openings allow for air intake, preventing negative pressure within the plenum. They also help to reduce moisture buildup. Design the louvers to prevent the ingress of rain and debris. Insulation reduces heat transfer, protecting surrounding equipment and personnel. Consider the operating temperature and the thermal properties of the insulation material. Safety labels clearly identify the plenum and warn of potential hazards. Follow applicable labeling standards and use durable, weather-resistant materials. Consider the effects of wind and snow loads on the plenum design. Ensure that the plenum is adequately supported and braced to withstand these loads. Inspect the plenum regularly for signs of damage or corrosion. Perform maintenance as needed to ensure proper operation and safety. Proper design, installation, and maintenance of the arc exhaust plenum are essential for protecting personnel and equipment in the event of an arc flash. Consult with qualified engineers and follow all applicable codes and standards. Review relevant documentation, including manufacturer specifications, UL 508A, and the National Electrical Code. These resources provide valuable information for designing and installing arc-resistant switchgear and exhaust plenums. Safety should be the top priority in all aspects of the design and installation process.